Hello friends, today we will see Z-level profiling. So for Z-level profiling I have this part and I will show you this. See, this is the part and this is my blank. Roughing I have already done. See, this is the roughing operation and cancel. And I will show you the verification, the material which is left after this cavity mill. Okay, so this amount of material will left after the cavity mill. Now I want to use Z level profiling. So Z level profiling steep, this is especially for steep area and you can also define the steep angle, and this toolpath will generate for the specific steep faces which you have defined. You can do this operation after roughing. We use Z level profiling for semi-finish and finish operation. Z level profiling is a fixed axis, means 3-axis program, and you can remove the material from the vertical face or steep face, depend upon the angle you have specified. The advantage of this Z level profiling, instead of cavity mill, you can do the same thing with the help of cavity mill with profile cut pattern, right? But here we have some extra advantage, means you don't need any blank geometry for Z level profiling, and it has steep containment, and it will work for depth level first, means it will first finish the first pocket or first island, then it will remove the second island. So we have few advantage over the cavity mill profile cut pattern. So here I need a tool. So first of all I'm going to define a tool and see, this is the tool. And again, no, I just want to use this tool, right? I'm going to use this tool. So click here and select the Z level profile steep, and the tool path is this one, and this is semi finish operation. Okay, and here you can see the tool is already defined. Steep containment is steep only. It means you can remove the material from the steep face only, and the steep angle is 60 degree. It means plane which are between 90 to 60 degree, vertical face and some taper face between 90 to 60 degree. All faces are steep in this condition. Merge distance, if you have any pocket and if you want to ignore that pocket, that cut out, so that amount is free. So if I am going to define this, means merge distance, if the pocket is less than 3, so it will automatically remove. Minimum cut length, the tool path will generate for the minimum length of 0.1 mm. Depth of cut I am using 0.5 for better finish, or here I am just using 1. Now just click and generate the toolpath. If you have not selected any cut geometry, it will select the whole part including this outer face. And see, the depth per cut is 1, so levels are so much. Let's wait and see. Here it is generating, but here I don't want, so move to geometry and here specify the cut geometry, and I want this upper face to be cut with the help of this operation. Now generate, and the material, the stock will be 0.25 after this operation. Okay, now it is okay, geometry is already done. Tool axis is G. Cut level we have already discussed in cavity mill. Strategy depth first. By default, it is depth first. If you want to change, you can change. Okay. And here, cut between label, we will see. First, see the toolpath is generated only for the steep area. If you will verify it, the toolpath is removing. So here you can see the toolpath is not properly just because of this blank. So okay this and okay, come to this geometry, and here it is under workpiece, but I want this to place after this. So drag and drop and it will move to next location. Now generate it. Okay, we will see. Now verify this. This is working only for the vertical face. You can see the toolpath is not generated for this area and for this area. But if you want to generate the toolpath for this whole, so double click here and come to this geometry, and here from geometry I'm just removing this face. Okay, and come to this strategy, and from strategy enable it cut between level, so the toolpath will generate for non-steep area also, and the step over will be equal to the depth of cut. Now generate. Still it is not creating the toolpath for this top face and this round face, because from main you have to change this steep containment none, means we are not just creating the toolpath for steep. Now we are creating toolpath for complete faces. Now verify and see. This is semi finished. Still 0.25 mm material is remaining, and corner also have some material because of tool dia. And if you feel the tool is colliding with the part, or holder is colliding with the part, so we can check it. Click this OK and OK. Right click over this part and report shortest tool. Here we will get the 65.1. Now come to this, double click here and 65. So increase this. Now 70, the length is 70. Now it is okay. See one more thing. Now it is okay, right? And I'm again changing some size of this tool so that it will reach on this area. Click here and generate. And see, right? So hope you understand this properly, and see you in next lecture. Hello friends, in this lecture we will see cavity mill, rest mill and Z-level profiling. And here we have some geometries. So first of all, I'm going to define workpiece. So click here. So first I need blank. So this is the blank, and this geometry I have already created in part modeling. And for check, these are some blocks, right? These are the cable. So select it. And for part, this is my part. So part, blank and check all are defined now. If you want, you can hide this blank now, right? And for these table also, if you don't feel comfortable, you can also hide this, but here it will work. So now I'm going to define a tool. So click here, and I'm using a tool. So tool width 10 mm, 0.8, and flute length is 10, and for length I'm using 55. Go to holder and assign a holder from the library, and I'm using medium compression. Okay, so tool is now defined, and enter the tool number. So this will help you while with creating the CNC program. This tool number will automatically add, right? Now, first of all, I'm using cavity mill for roughing. So select this tool, workpiece and roughing operation, and mill 10 R 0.8 rough operation. Okay. Now tool is defined. Here the cut pattern is follow part. Step over, I'm using 55. Depth of cut, I'm using 0.5. And from geometry, select the geometry, and this is my geometry. Okay, please remove these faces, and okay. Part stock is 0.5. Come to this strategy, it is all okay. No need to make any changes. From cutting, I am using depth first. Now generate. So first I have performed the roughing operation. Let's see the result. Then we will do rest milling, and later we will apply. See, we have only these things, this material we have, and for that material the tool path is generated. Let's see with 3D dynamic, and you can see because we have selected depth first, that's why it is cutting one depth, then second depth, right? So this is rough, okay, and okay. Now I need one more tool for rest mill. So click here and define one more tool. and okay, tool number is 2. Okay, click here and select this rest mill operation and select the tool, and this time same rough you can use. Containment in process workpiece, it will change from none to use 3D. You can also use cavity mill. In cavity mill, you have to make this change containment none to use 3D, and it will convert to rest mill, right? So right now I'm not using. Come to this geometry and here select this, okay, and generate. No part cut at any level. So the part stock is 1, so keep this 0.5, same as roughing. So this is just because the stock material is same as we have done in cavity mill. That's why. And second thing is, again it is level based. If you will select depth based, so it will a little bit more good. And here the part stock I'm selecting 0.2, and after that I will use one finish operation or any semi finish we can use with ball mill. So this is the tool path right now, and click here. Now see, okay, so rest milling works for the rest material which is left because of bigger tool, or material which is left because of stock you have specified in previous operation. So this operation removes the rest material, right? So rest milling is done now. Now I will apply Z level profile for one side, and then I will array it. Okay. Now click here and assign a new tool, ball mill 6. Okay, and float length 10 and 55 is the length. Okay, tool number 3. Okay, now click here and select this Z level profiling steep tool, rough, semi finish or finish, whatever you want. Okay, and here for steep select this none or steep, depend upon your angle. And here come to this geometry and select the specify the geometry. So I just want to remove material from this pocket. Okay, and for main it is okay, depth of cut 0.3, geometry is defined, tool is already defined, and generate. And one more thing, come to strategy and here cut between level. So steep, non-steep, both area will cut with this operation. And here, let's see the result. See, the stock amount is not defined. That's why it is not properly visible. Come to main, and here it is 0.1 because I am doing the semi-finish operation. Now, if you will see, result is much better. On the corner, some material is left on the corner because of bigger tool. Okay. Now, if you will see, the tool is retracting so much. So, come to this non-cutting, rapid and transfer. Here, within the region, transfer type, I am selecting direct. So, tool will directly approach from one label to another label without retracting up to the safety plane or clearance plane. Okay. Now, if you will see this in replay. Okay, so this is okay right now. Okay, now I want to array it, I want to rotate this, so we have two options. So this time I'm just telling you one transformation option, rotate. So select transform. I want to transform it with rotate about a point or line, rotate about the line. So this time I'm selecting line and point and vector. This is the method. So point is a center point, and vector will be z direction, and number angle, enter the angle is 120, and number of instance 2, 1 plus 2 means 3. So see this. Okay, see the first one, second one, and third one, right? If you will select all these and verify, click here and check this. Now the second pocket which we had transformed. Okay, so hope you understand this properly. If you have any query, you can comment me, you can text me. Thank you for watching. Have a nice day.
Friends, today we will see Z level corner. So this Z level corner is not a separate operation here. So we will do this operation with the help of Z level profiling steep. So most of the time while we have some small area which are steep area, so we can use Z level corner for steep areas. So here I am going to use a smaller tool. This tool I am going to use to cut these 1, 2, 3, 4, 5, 6, 5 slot which are vertical faces. Now click here and select this option Z level profile steep and select this ANSI program. Tool is defined and workpiece is this one. Okay. Now just keep this steep only because all the faces are vertical or near about vertical. Maybe a slightly draft will be there, 1 or 2 degree. Still, it is vertical. So come to geometry, and here I am selecting the cutting area. So I have few tangent face, 1, add 2, add 3, and the next one. Right, so all 6 face I have selected. Stock, I don't want any stock, so this will be a finish operation. Come to this strategy, and here I am using depth first, and I just want to cut the steep area, so I'm not selecting this cut between level, and I don't want to use this option reference tool. We will use in next example, right? So generate this. See, the toolpath is generated. Still, you can see the non-cutting moves are, these all blue lines are retracting. So I want to reduce it. So go to non-cutting move and rapid and transfer. Here we will change it to direct, so the transfer will not be up to the clearance plane or safety plane. So it will direct. Now I want to check it. So say this. Few operation already has been done. Now see this. So we can use this Z level corner, or you can say Z level profile for steep area. Okay, and okay. I have one more example. See, in this part I have already done a roughing operation. One, Z level profiling. Now verify it, and we will see the result. Because I have used a bigger tool for this operation, now I want to use a smaller tool for rest of the material which is available on the corners after cutting this. This will work like the rest mill for Z level steep. Okay, so because of bigger tool, maybe some material is there on the corner. So for next operation, and check one more thing, double click here, and the stock is 0.25, so we will keep this 0.25 for our next operation. Click here, and here the program folder, and the tool is this ball mill. Come to this, and here is a workpiece one. Right, I don't want this, keep the semi finish, and from geometry 0.25. If you want to select geometry, select the cutting area, and now come to this strategy, and here in strategy we have reference tool. Now select the reference tool, and the reference tool is this one. So select the same previous tool. So material which is left by the previous tool will be cut by the current tool. Now generate. See, the extra material will cut, and if you don't want, select this direct on part and generate. Non-cutting move will reduce. Here it is not possible. So ramp on part, let me check. So again it is not working. So come to this, and here a rapid and transfer. Now use the direct option. Now see. Okay. Now let me check. So this will cut on the corner. So hope you understand this, how to use this Z label profiling with reference tool, or you can say Z label corner.